Welcome to CS 179 Networking 1. I am your instructor, Robert McMillen, and we're going to be using the book Managing and Troubleshooting Networks by Mike Myers. That's the third edition, and we are at Clackamas Community College. So let's talk about networking. Today we're going to be working with Chapter 2, which is Network Models. And that's going to cover things like the OSI model, the internet model, and various different layers, and also look at network hardware and TCP/IP. There are three different parts to understanding networking, and the first part is the concepts. So how does data move from one computer to another over a network, and the theories of how networks operate. Next thing is the technologies that we use today, how those theories are implemented, and how do they work? How do they use applications? So we're going to talk about that in this class. And management of networking technologies. Of course, you've got to secure your network, you've got to design your network, and you've got to manage it. So we're going to talk about all those different areas. So let's take a look right now at a local area network, or a LAN. So if you look at the typical LAN, in the center of the LAN is going to be your switch. That's where everything is ultimately going to be connected. And of course, if you want to get outside of the LAN into the WAN, you have to have a router or firewall that takes you out into the internet cloud. And connected to that switch, of course, you have all your different servers. In this case, you've got a print server, web server, and file server. And we also have client computers as well. Now you see this printer here, it could be physically connected to the print server and shared that way, or it could be connected to the switch and then shared through a print queue. So there's a couple different ways to do it, but ultimately the switch is where everything is connected. Let's talk about the network types. You've got the local area network, which I just showed you, and that is typically in an office, but it could also be in a home or other area where that's all self-enclosed. Then you've got backbone networks. Those are less than a few kilometers. It's a high-speed backbone linking together different LANs at various locations. Now, there is some confusion between a backbone network and a metropolitan area network. That's a little bit different. You can be farther away in a MAN situation where it's more than a few kilometers. It connects LANs and backbone networks across different locations. It also can use leased lines or other services. So it's not going to use the same technology, or doesn't have to, throughout the entire metropolitan area. You could have multiple different ones. So if you have a business with several different locations in that same region, then you can have a MAN set up using different internet service providers, different technologies, that kind of thing, to have them all connect together. And of course, the one that covers the greatest distance is going to be a wide area network. It's farther than 10 kilometers. It's the same as the MAN type of network. It's just over a much wider scale. LANs and backbones. So this gives you a little bit of a graphical view of what we just talked about. So you have your LAN, you have your MAN, you have your backbone over here, and you have your WAN. So you can kind of see the different areas that could cover in a graphical way. So when we talk about the internet, we can't fully discuss that without also covering the intranet and the extranet. So an intranet is a LAN that uses the internet technologies inside an organization. So in that LAN type of situation we just discussed, if you had a web server that was only serving the people inside that LAN, that would be called an intranet, because it never actually leaves the area. Open to only those inside the organization, so you may have just your employees, for instance, access that. An extranet is a little bit different. It's also going to be inside a LAN, but it also allows some external people to connect into it. So say, for instance, you have an intranet, but you also open it up to some customers to log in to check things like stock, inventory, other things like that. That would now be considered an extranet. Multi-layer network models. The two most important such network models are the OSI and the Internet model. So some people like to refer to the OSI model. Some people like to refer to the Internet model. So the OSI model was created by the ISO, International Standards Organization, back in 1984, and it's based on seven different layers, which we'll talk about in a minute. Whereas the Internet model was created by DARPA. These are the people that have initially created the Internet in the early 70s, and they developed it to solve the problem of internetworking. Well, they also used it to figure out a way to blow up a nuclear weapon or launch a nuclear weapon using our telephone system, and they knew that at that time that our telephone system was so layered and so complex that if a nuclear weapon came in to destroy one area, it would not take down the entire phone system. It would find another way around. So that's why that was originally created. And it was also created to be used by scientists to collaborate with each other. It was never originally created for everyone to have access to it, which is one of the reasons why it has so many security problems. It is mainly based on the TCP/IP suite. TCP sits at one layer, whereas IP sits at another layer, which we'll talk about. So we have the 7-layer model OSI. So the OSI one, as I mentioned earlier, has 7 layers. You've got the physical layer, the data link, network, transport, session, presentation, application. Definitely recommend that you memorize those 7 layers if you take any kinds of tests, especially certification tests, because they constantly ask about these different layers. The application layer is a set of utilities used by application programs. So application layer programs, say Microsoft Word, for instance, that would be used at the application layer. Presentation layer formats data for presentation to the user, so it takes it one step down. Provides data interfaces, compression, translation, that kind of thing to the different formats. And that takes us down to the session layer. Now, none of these layers communicate directly with all the different layers. They only communicate with the layer that's above or below them. And that's one of the great things about the model, is that you can't have one layer crash the entire system. So the session layer initiates, maintains, and terminates each logical session. So it sets it up and it tears down the connection. The transport layer, this deals with end-to-end connection issues, such as segmenting the messages for network transport and maintaining the logical connections between sender and receiver. So, for instance, in TCP/IP, the TCP portion sits at the transport layer, and the IP portion sits at the network layer. This is responsible for making routing decisions, which is one of the reasons why at the network layer, routers sit at this particular layer. Data link layer deals with message delineation, error control, and network medium access control. So this is one of those things where the switches sit, and also bridges. They sit at the data link layer. So where everything is physically connected, that's going to be the data link layer. Also handles frames as well, Ethernet frames and various other different types of frames, which we'll talk about later. The physical layer defines how individual bits are formatted to be transmitted through the network. So this is where most of the translation happens between other topologies and protocols and into your computer. So you've got your network card. That sits at the physical layer. And the network card has a MAC address, which is a physical address, on the card itself, and that never changes, although some devices do allow you to change it, but regular network cards that come in computers do not. So the network layer is where the IP address actually sits, but the physical address sits at the physical layer. So there's a comparison between the OSI model and the Internet model, which was developed by DARPA. So the OSI model, so you see all the different 7 layers, and the Internet model, the first 3 layers are all tied up in the application layer. Then it goes down to the transport, and everything else is the same after that. So you can have groups of layers. Sometimes we call the application layer out, which we really refer to the first 3 layers of the OSI model. The internetwork layer we refer to as the transport and network layer, and the hardware layer we refer to as the data link and physical. And here are some examples. So let's take a look at data as it travels from one computer to the next. So if you are the sender, you are going to send a packet over to the receiver, which may be a server in this case. So let's just say you're sending off an email. So you open up your email application such as Outlook or Thunderbird, whatever it is you're using, and you send an email. Well, it travels from that application layer down through the presentation, session, et cetera, until it finally gets to the NIC. Then it goes over into the switch and then back to the other person's NIC, and then it travels back up into the email application at the top. And then, of course, the procedure goes in reverse when the receiver becomes the sender, and it goes back over to the original person. So this is how data is transported. It doesn't go from application to application. It goes all the way down and then all the way back up. Message transmission example, as mentioned before, this is just using the HTTP request for, say, a web page, and it makes its way through. And this is more of the other type of model, which is the DARPA model. You have the application, transport, network, data link, physical, and it comes back up again. So you see a couple of the different layers missing here because it's the other model. All right, so let's talk about the network layer view. And layers allow simplicity of networking in some ways. It's easy to develop new software. So when programmers create software, they don't have to develop it for all 7 layers. They just develop it for the layer that they want to use it in. So that's one of the great things about the OSI or the network model. So matching layers communicate between different computers and computer platforms, so you don't have to have the same brand of computer, which was the problem when the internet was first trying to be developed. Everybody had their own standards. Now we don't have to worry about that. Although there are some drawbacks, it involves many software packages and packets. There's a lot of overhead, so things run slowly, but in general, it does work pretty well. All right, so there's some major standards bodies that come up with the standards that we use for the internet and for applications and all things in communications. There is a standards. So starting out with the ISO, which is the International Organization for Standardization, they have technical recommendations. They're composed of each country's national standards, and it's based in Geneva, Switzerland, although we won't hold that against them. ITU-T, which is the International Telecommunications Union, the technical recommendations about telephone and telegraph, although strangely enough, some still use the telegraph, and data communications interfaces, composed of representatives from each country in the UN. So if you're not in the UN, you don't have a say. And again, based in Geneva. All right, you also have ANSI, which is the American National Standards Institute. Basically, they just take the information from the ISO and then they make it available for people in our country. It doesn't actually make standards itself. Now, the IEEE Institute, that is a big one. They come out with all the 802.1234 all the way through. 11 is, of course, a popular one for wireless. And that stands for, the 802 part stands for 1980 February. So it's the second month of 1980. So that's what then they came out with all those 802 standards, or the initial 802 standards, and then they just keep getting added onto over the years. The IETF, which develops internet standards. There's no official membership, so anybody can go join up and take a look at it. But they are out there as well, and they'll come up with internet standards, both now and in the future. And let's take a look at some datacom standards. So we've got under application layer, a common standard would be HTTP, which we use to access web pages, HTML, which is the program language we use to create those, MPEG for video and email, etc. Of course, not many people still use IMAP and POP, but that's still out there. The transport layer is TCP over IP with the network layer, works together. And if you still have an old Novell network, they're still out there. You can have SPX over IPX. Then you have data link, which is Ethernet, frame relay, T1. Those are just a few examples. There's a lot more than that. And then you have the physical layer, which is the cable, the NIC, the LAN, the modem, if you still use those. Integration of voice, video, and data, also called convergence. You're going to see this a lot over the years because we used to have everything separate from each other, such as internet data was separate from phones, and that was separate from alarm systems, and that was separate from other things. Now, convergence sort of makes all these different technologies work together using TCP/IP. So we're going to see a lot more of that in the future. So to summarize, talked about the network layers, the OSI model, and coming up we've got what device lives at each layer, such as the routers live at the network layer, and how do they interact with each other. So they'll be coming up in future modules, and stay tuned for module 2, and thanks for joining.